Those digital circuits that we just talked about form the basis of all of these microcontrollers, microprocessors that you're familiar with today. So those adding circuits in particular would go in here into this ALU, or arithmetic logic unit, and along with some control circuitry, also typically formed from digital logic circuits, we form what ultimately can compose a microcontroller or a microprocessor, or what we often simplify to micros. So there are a lot of different kinds of micros. Microprocessors will be one that you're probably most familiar with. Those can be found in your smartphone or in your laptop. That's a CPU only. A CPU is a central processing unit, which is effectively this block over here. These are fast, they're relatively expensive, also typically very power hungry. They actually require you to plug them into a wall, at least on a relatively frequent basis, as in the case of your phone. Microcontrollers are another kind of micro. In this case, you get a CPU plus what we call peripherals, and that could be memory, it could be digital I/O. I/O is input-output, clocks, communication, analog I/O even. And it sounds like you're getting more, but typically these are a lot slower. And as a result, they're inexpensive. They're also lower power in general. And obviously you have a range in between these two things as well. Finally, you have a variety of other things, and we might call those ASICs, which are analog application-specific integrated circuits. You have DSPs, which are digital signal processors, and you have FPGAs, which are basically huge combinations of all those digital logic gates that we call field programmable gate arrays. So they're just a bunch of logic gates, but I can program them by programming how those gates are connected. The Arduino that you're going to be using in this class, in lab, and that some of you have used in the past, we're using the Arduino Uno here. This is not a microcontroller. The Arduino is the full board here. What is a microcontroller is this particular chip right here, and if you have a different version of the Arduino Uno, you might have a different looking chip. It might be a surface mount chip instead of this dual inline package that you see here. This is an Atmega 328, which is a specific type of microcontroller manufactured by Atmel. But combining that microcontroller with all of this other stuff that's on this board means I can do a lot of pretty cool things. So for example, I have my USB connector right here, and that can give me both power and communications that I'll write as comms here. I have another power port if I want to plug this into the wall, just with a power brick. And I also have some power pins right here. This one is 5 volts over here, and I have V in if I want something other than 5 volts coming in here. I also have 3.3 volts, and then these two in the middle are going to be ground. And in addition to this, I have a ton of other kind of cool functionality. So all of these that are labeled A over here, these are going to be analog inputs. So I can actually connect these up to sensors that you'll do in the lab and actually read inputs, analog inputs from those sensors. Obviously they're converted to digital at some point, and we'll talk about those analog to digital converters. Up here, I have a whole bunch of digital I/O. So those are digital inputs, outputs. Down here, these are only analog inputs. I don't have any analog outputs on the Uno, but these are I can use either as digital inputs or outputs. And digital are ones and zeros, or in the case of the Arduino, 0 volts or 5 volts. And I have a number of other kind of cool things that I can look at. I have an LED right here, and that LED can be useful for a lot of different things, telling me that I'm actually seeing things correctly or not. I have these little marks right here, for example. These are what we call PWM outputs, and I can kind of think of these as a pseudo analog output. I can filter them and use them as an analog output as well. And then there's another number of other things. So I have a reset button here if I want to kind of restart everything. These are crystals that are forming clocks. These are giant capacitors. There's a lot of other different pins that I can access on here as well. And I can make that Arduino even more powerful if I connect that up to circuits that I build myself. And I might build those circuits on a solderless breadboard that you have in your parts kit. And so the way a breadboard works is typically I have these buses along the edges. So this huge thing along here, all of these pins are connected. And typically I'm going to make this line right here my ground. The minus is what I'm typically going to be using as ground, although you can really do whatever you want there. And then all of these are going to be connected as well, and typically I'm going to connect that up to my plus 5 volts. And I have the same thing over here, so oftentimes I will just connect a wire from this edge to this pin over here. And I'll do the same for my ground here. I connect a wire here to here. So now this line is all 5 volts and this line is all ground. And everything else in between these lines right here, kind of depicted horizontally, but often I can think of them as vertical lines. These lines are all connected to each other, but these big columns are not going to be connected to each other. So all of these pins are connected, but those aren't connected to the next row down, if that makes sense. And then obviously I can use this breadboard to plug in a variety of discrete components, maybe an LED, maybe some resistors or capacitors, and build a circuit that I can interface to my Arduino, connect ultimately sensors, or connect my Arduino up to actuators that would form our full mechatronic system. In the software world, if I'm writing my first program, often I write a program called Hello World, and that's going to display the words Hello World on my screen. In mechatronics, often the first thing I do is turn on an LED. And to do that, we're going to do that in the simplest way possible to start. So I'm going to have a current limiting resistor and an LED, which I draw as a diode. An LED is a light emitting diode. And this is R, maybe that's around a kilo ohm or say 470 ohms. And this is maybe a red LED or a yellow LED. And to connect this up, I want to connect each side of these to power and to ground respectively. So to connect this to power, I'm going to connect a wire to my 5 volt port right here. And for ground, I'm going to connect the other side to one of my ground ports on my Arduino like this. And if I do this, this LED should turn on, assuming I have power plugged in through the USB or the alternate power port. Let's do the same thing on the actual Arduino and breadboard. So you'll notice I have no LEDs on currently on my Arduino, and that's because I don't have power plugged in right now. And it's always best to set up your circuit without power plugged in. Once you've checked it twice, then you can plug in power. So to do this, I'm going to connect the 5 volt pin on my Arduino and the ground pin to my breadboard. And now that I've done that, all of these pins on the breadboard are going to be connected to 5 volts. All of these blue line pins are going to be connected to ground. And for the meat of this circuit, I'm going to require a resistor and a diode. So I'm going to use a 330 ohm resistor from your kit. And I'm going to connect that from that 5 volt bus to one of these columns in the breadboard. And to that I'm going to connect an LED. And you notice there are two length wires coming out of this LED. The longer wire is going to be the anode, and the shorter wire is going to be the cathode. So I'm going to connect the longer wire to the resistor side and the shorter wire to the next column over. And finally I'm going to connect that to ground with another wire here. Alright, so I have the entire circuit wired up. I have the resistor connected to 5 volts. That is connected to the anode side of the LED. Cathode side is connected to ground. And when I plug in the Arduino, voila, I have an LED that is lit. Hello world.